Alrighty, so now that we have an understanding of how to factor out the greatest common factor from a polynomial, we are going to do a different kind of method that we will use in our next unit. So it's very important that you take time to grasp this idea because you will need to use this method in our next unit. But without further ado, let's start talking about what this idea of factoring by grouping means. And it is a technique that is specifically designed for polynomials with 4 terms. And this method works by splitting the polynomial into 2 separate pairs and finding the greatest common factor of each pair individually. So looking at example 1, we are asked to factor the following polynomials using the factoring by grouping method. So for example 1, we have 2x cubed minus 4x squared plus 15x minus 30. So what I'm going to do is I'm going to group these first 2 terms together as a pair and these second 2 terms together as a pair. And when I do that, for these first 2 terms here, I have to ask myself, what can I factor out? Or in other words, what's the greatest common factor of these 2 terms here? And seeing that both of these have a 2 and a 4, I can divide them out by 2. And then both of them have a variable x, and the smallest power is 2. So I'm going to factor out a 2x squared. And when I do that, this inner part is going to be 2x cubed divided by 2x squared, just becomes x. And then negative 4x squared divided by 2x squared just becomes a negative 2. And now I'm going to add the second part. So we're going to do the same exact process. So we're going to have to figure out what is the greatest common factor of these 2 terms here. And because this constant here doesn't have a variable or it doesn't have an x, we're only going to be factoring out 15. And when we do that, we get x minus 2 here. And then we have one last step here. So looking at these 2 factors, notice that the x minus 2 and the x minus 2 are identical. That's a very important step. So if you are doing this method, factoring by grouping, and you don't get these two binomials don't match up, then you need to go back and check your work. And once they do match up, we can simply rewrite this here as a product. So I'm going to go ahead and write this x minus 2 over here. And then I'm going to write what's left over, this 2x squared plus this 15, as a product here. And now you might be asking, how did you go from here to here? And the answer is if you were to multiply these 2 binomials together using the box method, you'd end up getting the same exact 4-term polynomial here. Alrighty. So taking a look at example 2, I encourage you to pause the video and try this one on your own. The process is going to be exactly the same as before. Now let's go through this together. So I'm going to go ahead and find the greatest common factor within the first 2 terms. And here we can factor out a 3 and an x squared. And when we do that, the inner part is going to be just x, because 3x cubed divided by 3x squared is just x. And then we're going to add 15 divided by 3 is 5, and x squared divided by x squared is just 1. So we're going to have x plus 5 here. And then here, with the second 2 terms, I can factor out a 6. So in the inner part, we're going to get x plus 5, because 30 divided by 6 is 5. And now, these 2 binomials here, they match, which is good. That's what we want. So now let's just go ahead and rewrite these as a product. So we're going to have x plus 5 times 3x squared plus 6. And that's your final answer. Taking a look at example 3, we have 7x to the 5th power minus 14x to the 4th power plus 2x squared minus 4x. So I'm going to first start off by finding the greatest common factor in both these terms here. So here I can factor out a 7 and then an x to the 4th. And when I do that, here I'm going to get an x minus 2. And then I'm going to add here for the second, or for the two other pairs, we can factor out a 2 and an x. And when I do that, you're going to get x minus 2. And now we have to check, do our binomials here match up? And they do. So now we can go ahead and rewrite these as a product. So we're going to have x minus 2 and 7x to the 4th times 2, or plus 2x. Now, one thing to notice here is that both these terms within this binomial, we can factor out an x. So when we do that, we're going to get x minus 2 times x. And then here we're going to get 7x cubed plus 2. And here, I don't really like this x being in the middle here, so I'm just going to simply write this x over here in the front for our final answer. So we're going to have x times x minus 2 times 7x cubed plus 2 as our final answer. Alrighty, so I encourage you to pause the video and go through this final example on your own. And assuming you have given it a go, let's go through it. So if you looked at this and said, this doesn't look like how it usually looks like, you are correct. But the only difference between this example and the other ones is that this polynomial here isn't in standard form, but it's nothing different compared to what we've been working with. So let's first just start off by rewriting this in standard form. So remember, standard form, we're going to write the exponents in descending order from left to right. So here we're going to have m cubed minus m squared plus 2m minus 2. And now let's do our factoring by grouping. I'm going to first find what the greatest common factor is in the first pair here, and I can factor it in m squared. And when I do that, I get m minus 1. And then I'm going to add 2m minus 2. I can go ahead and factor out a 2. And when I do that, we get m minus 1. And our binomials here match. So we can go ahead and rewrite this as a product. So we get m minus 1 times m squared plus 2. And that's it. That's your final answer.